Hello friends, welcome to Python tutorial course. In this video, we will be looking into how object copy works in a Python, and as a part of that, we will focus on shallow copy versus deep copy and its behavior. So let's get started. Here I have source object with three members, which is M1, M2 and M3. M1 points to value V1 in the memory, M2 points to V2 and M3 points to V3. So here actually V1, V2 and V3 are actual data values in the memory, and M1, M2 and M3 are just references to those values. So whenever we want to copy any object in the Python, usually what we do, we use either assignment operator or we use the copy method provided by the Python. So let's say whenever we are saying target object equals to source object, you may think that it will create completely different target object which will have its own copies of V1, V2 and V3. But that's not the case because a shallow copy just create a new object which stores only the references to original values. So here in this case, whenever we are creating target object, the M1 will point to V1, M2 will point to V2 and M3 will point to V3. V1, V2 and V3 is the same memory area which is referenced by the source object itself. So basically both the objects, source object and target object will point to the same memory area V1, V2 and V3 whenever we use this assignment operator or copy function. This is called a shallow copy because we don't have separate memory area for the target object which will hold the values for V1, V2 and V3. The memory area is shared between the source object and target object. So what will happen in case of any modifications? Let's say I want to change a value for V2 only for the target object, but that's not possible because that memory area is shared between two objects. Hence, whenever we change the value of V2 for target object, the changed value will appear in source object as well. So any modification made to V1, V2, V3 will be available in both the object, source object as well as in target object. Let's just see some of the Python examples around this. This will make things more clear to us. See here, I have created two lists, list one having integer items and list two having characters. Now I will create my source object using this two lists. So source equal to, I'll create a list with list one and the second item will be my list two. I'll just print my contents of the source object and also the ID for my source object. So here I'll just print and just check its values. Okay. So source object contains two lists, which is 1, 2, 3 and ABC because I have created source object with this two list. And the ID for this source object ends with 1344. Now let's just create another object, which is target using my source. So I'll simply say so target equal to source. And now I will print the contents for my target list. Okay. Here, if we see, my target list also has printed the same contents 1, 2, 3, ABC, and the ID is also same because I have just used assignment operator, so it will point to the same object. Now let's just say I just want to change value of my target object and not the source object. So what I'll do, I'll simply say target of 0. So basically I want to replace this value 1 with some different item. And in my target list, this is my first item. So I'll say target of 0. And from the 0th item, I just want to change the 0th element. Okay, I want to set its value to, let's say, I'll say it as new item, for example. And let's just print the contents of target now after changing this value. So if you notice here, in my target list, the new item, the basically the one is replaced with the new item and rest of the things will remain same. But I just wanted to change the contents of target list and not the source list. But let's just print the source list as well now. If you notice the difference here, source list is also printing the change list. That means whenever we had created this target object, It has not allocated any different memory area. Instead, it is just a reference to the same source object which we had created earlier. That's why any changes made to either source object or either target object will be visible to both. Here we have just changed value for the target object, but still the changes are visible into source object as well. So here we have actually noticed that the object copy process does not actually recurse through the complete object and does not copy the nested object itself. It just copy only the references. That's why it is called as shallow copy. Now let's just see how deep copy works in a Python. In order to make a deep copy of an object, Python provides its own native function. In Python, we can use deep copy function to create a deep copy of an object. So I'll take the same example where I have source object with three different members, M1, M2, and M3, and each pointing to its corresponding values V1, V2, and V3 in the memory. When I create the deep copy of a source object using deep copy method from the Python, completely new memory area will be allocated for the target object, and deep copy will create new object and also will recursively copy all the elements from the source object to the target objects. So basically source object will have its own memory area where it will have value v1, v2, v3, and target object will have its own memory area where it will have its own copy of v1, v2, and v3, so that any modifications made into either source area or target area will not be visible to each other. Let's say if we modify value v1, v2, and v3 from the target object, those changes will not be available to source object and vice versa. This is what we call it as a deep copy, because as a part of deep copy, all the nested objects are also copied from the source object to the target object. Now let's just see the example for deep copy. I'll take the same example, whatever we had used for the shallow copy. So here I have list 1 and list 2. Also I have created a source object with list 1 and list 2. Let's just print the contents for the source object, and now I'll create the target object from the source. So while creating target object, I'll simply use copy, and this copy module has a function called as deep copy. Then I'll just pass the source object to it and we'll print the target object detail. Let's just see what details it is printing right now. Okay. So in earlier case, in case of shallow copy, we had observed that the ID for source ID and target ID was same. But here, if you notice, the ID for source object and target object is different. Now also try to modify some value from the target object. Let's say for target, I will change the same value, 0, 0. I'll set it to new item, and we'll change the contents of the target again after modifying the value. So if you see the difference now, for the target, the value is changed, but now let's just check the source, if the source value is also modified or not. Okay, I am printing the source value again at the end. So please note the difference here. Only the target value is changed and not the source value, because as I mentioned, the memory for the source and target object with the deep copy, it's completely different. Whenever we had created a deep copy of a source object, actually it has copied all the data from source object to the target object. And after that, even if we make any changes to either source object or target object, those changes will not be visible to each other because the memory location is completely different for the source and target. So let's just summarize the difference between shallow copy and a deep copy. So in case of shallow copy, when we copy one object into another, only the references will be copied and the target object will also point to the same object where source is pointing. So both the object can share the memory location. That's why the changes made to one object will be visible to another object in case of shallow copy. In case of deep copy, whenever we copy an object into another, complete references along with its data is copied into the target object. Hence, the target object will have completely different memory location. That's why the changes made to one object will not be visible to different object. When we want to use the shallow copy and deep copy. So please keep in mind that deep copies are costly because it is copying all the items or the data from source object to target objects. So it might be memory heavy if the objects are bigger. So we will have to use the deep copies cautiously. If your data is not being manipulated, then one can always use shallow copy. But if two different threads processes are making manipulation into the data, then we will have to make a deep copy of an object so that two different processes, two different threads can work on the say work on its own copies of the data. So that's it for the shallow copy and deep copy. Please subscribe to the TechShare channel for more such interesting topics. Thank you.